This topic is synthetic division. Please make sure you look in your book on page 137 with the explanation of that you can only do synthetic division when you have factors that are x plus or minus some constant. The definition you can read on your own too. Synthetic division is a shortcut method for dividing a polynomial by a linear factor x minus a. It can be used in place of the standard long division algorithm. This is a faster method, but doesn't always work, remember. This method reduces the polynomial and the linear factor into a set of numeric values. After these values are processed, the resulting set of numeric outputs is used to construct the polynomial quotient and the polynomial remainder. Let's go ahead and show you an example. So here's taking a polynomial, 3x cubed minus 7x squared, 17x squared plus 15x minus 25. And we want to divide it by x minus 5. So this is our factor right here. We want to factor this out. So we have to make sure that it's x plus or minus k, which it is. So we're going to set this factor equal to 0 and solve for x to get our k. So we're using like that, kind of like we do like the zero product property to find our factors and our zeros of the function. So we add 5 to both sides. So this is the number we're going to work with. This 5 is going to go out in front. Now I've already set up part of the synthetic division box. I have an x cubed placeholder. I have an x squared placeholder. I have an x placeholder. And then I have a constant. Now what we're going to do is we're going to go ahead and write down what those coefficients and constants are. So our 3 is going to go right here underneath the x cubed. Our negative 17x squared is going to go under the x squared term. The 15 is going to go underneath the x spot. And then here is our constant, minus 25. Now we're set to do our synthetic division. You may just want to watch this process in its entirety and then go back and write the problem yourself. So step 1 in synthetic division is always to bring down this first term. And now everything underneath here, we are always going to multiply to this 5. So we say 3 times 5 is 15. That's going to go in our first place. And now we always add the columns. So negative 17 plus 15 is negative 2. Now we multiply. 5 times negative 2 is negative 10. That's going to go right underneath here. And now we add the columns. Negative 15 plus 10 is 5. Now we multiply. 5 times 5 is 25. Add the column. Negative 25 plus 25 is 0. This is our remainder. There isn't any, which is good. We hopefully want remainders to be 0. What that means if your remainder is 0, it means it's factorable. So then I will reduce this polynomial by 1 degree. If this was an x cubed, I'm going to drop this to x squared. Next term is an x. Next term is my constant, and then my remainder. So we wanted to factor out 3x cubed minus 7x squared plus 15x minus 25 and x minus 5 out. So we say 3x cubed minus 7x squared plus 15x minus 25. If we want to factor out an x minus 5, what we're left with is this long division piece in the purple and green. So we say equals, I'm going to go x minus 5 as our factor, and then 3x squared minus 2x plus 5. Where I got that from is right here, 3x squared minus 2x, and then that plus 5. I could then go out and continue factoring the trinomial in the blue. I could probably use AC method and see if that was factorable to make this completely factorized.